welcome, at least also from my side. Thanks for the introduction and the start. Yeah, looking forward to sharing Kotlin with you all, at least from a perspective of a Java developer. Feel free to ask questions in between, raise your hands or ask in the chat. Also some Kotlin knowledge experience there. I'm going to talk a bit on introduction. So I'm starting a bit with some concepts. I'm also curious about maybe some questions from your side, and then we are also having some further experiences on that area from Ralph later. See on the monitor. So I'll also switch in between PowerPoint and coding. Yeah, quite nice to have that back. So yeah, I'm shortly doing an introduction also on my persona, so maybe keep that shorter. Then we're going to take a look on features of Kotlin, some things that I personally like, some language decisions that you should be aware of, and then also a bit further topics where you can take a look at what is happening also on Kotlin next year. And then, yeah, we'll have a question session in the end. So yeah, Sebastian started already a bit on my persona. So I'm part of LeanIX since August. I'm full stack software developer and Scrum Master. So I've been developing in Java, Groovy, Kotlin, Go quite often. Also a bit of Rust and Python. Yeah, last couple of years I've been working on Kotlin and Java and a bit of in Go at work. Before joining LeanIX, I've been head of software development at ViaVox, where yeah, we've been using Spring in Java and with Kotlin. And before that, did my PhD, or started that on gamification for software development or software developers, taught some software engineering lectures. And yeah, since 2011, I'm co-founder and co-author on the One Agile meetup and have been part of many meetups in this area for the last over 10 years now. And yeah, living here in Königswinter and Stieldorf up the hill. So let's start with a bit of fun in Kotlin. If I'm too fast, always feel free also to ask back a bit. Of course, yeah, I've been doing this for quite a while already. So Kotlin, classical question, yet another new JVM language. So there have been tons of new JVM languages that were always the best. So Groovy, Scala, and numerous others, Clojure and Kotlin now for a while. So Kotlin was created in 2010 by JetBrains, that you know from IntelliJ. It was open source in 2012. It's named from the Kotlin island in Russia. So there were a lot of beta versions, 0. whatever, and then the first stable 1.0 version was released in 2016, which was a quite nice milestone back at that time. And since then, the language has evolved, but it's still compatible. So they always say you can still run 1.0 projects with the current version. The latest one has now been released in November. And yeah, so there has been a lot of traction. So I've collected some of the bigger companies that officially say they are Kotlin, or also some are major Kotlin users. I guess you know a lot of these people, of these companies. I guess a lot of that has been doing Google. So Google in 2019 declared that Kotlin is the preferred language for Android. So as this was a major shocker back then, I still remember that quite vividly. But yeah, it has been developed quite fast, and also a lot of features in Kotlin have been developed since then. And I've seen a statistics the last time that now 2/3 of the apps in the App Store are in Kotlin. So that's a major breakthrough there. And also in the JVM department, there's been a lot of switching. So Spring has the official Kotlin support since version 5 in 2017. And they've translated all documentation, for example, with Kotlin first. So if you want to use Kotlin with Spring, you will always find at least the Kotlin snippets and whatever. And if you've been using, of course, Gradle as a Java developer, you've also seen that they are now using Kotlin as main language and also have all examples there. Funny enough, whatever, you need to fake your own statistics also. Kotlin is the fourth most loved programming language in the Stack Overflow developer survey from last year. I've never heard of that survey before, but yeah, I need to pick your own surveys to say that you're good. And I started with Kotlin, yet another new JVM language. That's of course on the one side true, but the fun thing and interesting thing is that Kotlin is even a multi-platform language. So you can generate not only to Java bytecode, but you can generate and use JavaScript with it. It compiles to native, it compiles to mobile, to Swift, and to Android, of course. That's one of the languages there. But this has a lot of impact also on the language as you can broaden your scope. And there have been a lot of languages that try to do that, but so far Kotlin is one of the current ones that seems to be able to be on these platforms as well. So one small question in the round, if you want to type in the chat or raise your hand. So who has experience with Kotlin? I would be curious about that. Anyone? Yeah. At least Sönke. Yeah. At least a few. At least something. So that's at least something, and more than I even expected, but all of us are from Linux, I guess. Good sign. Let's see how that goes. So let's take a look at the language a bit from a Java perspective. A lot seems similar, some things seem different. So the classical one, you'll see that the language, so you are writing the types on the right side again, not on the left. This is also, if you have some other languages, I guess in Python with the type hinting now, you also write it on the right side. You have fun for functions, so there's a lot of fun in Kotlin. And you also have some other syntax in between where you at least have some smaller syntax and some easier syntax that you're seeing step by step. And overall, it looks like Java, kind of. So it's still similar. That's also something that you're going to hear from me. So if you are working with Kotlin, or if you are even have a Java project, you can use Kotlin in that. And you can use everything from Java in Kotlin, and you can use Kotlin from Java. So there's no difference where you want to go and how you want to start with it. So there's not, you need to do Kotlin and never do Java again, which is also quite nice. So in the end, there are a lot of language features that I want you at least to introduce you a bit. So I would at least be biased to say Java has, of course, its benefits. So I always say every language has its pros and its cons. Java also has a lot of pros. It also has some cons. I think that Kotlin improves a lot of these cons. And I wanted to show you a bit on the features of Kotlin, to show you a bit what it can do, what I think is also nice, but also remind you a bit of obstacles that you might encounter. And then you can hopefully decide a bit more if that's interesting for you or not. Are there any questions so far? Then let's talk about features. One of the core features, I would say, in Kotlin, one of these is Null Safety, which is kind of a nightmare sometimes in Java, where you get a type and you have no clue and you have millions of null checks and you still have your fun null pointer exceptions, sometimes even on production. So this is always, it always feels like a nightmare and a misconception in the language on the long term. And this is one of the things where I really believe that Kotlin is shining. So you have a difference where you can define the type if it's nullable or not. So that's the question mark here. So in this example on the right side, so I have a non-null type, I just write a string, and by default this then means this cannot be null. So if I'm writing then safe equals to null, I get a compilation error, which is quite nice. And I really need to have a nullable type to be able to assign null to it, otherwise my code not even compiles. And I can also then use this in code. For example, with the Elvis, the not safe question mark dot length would call the length if not safe is not null, and otherwise I get that length 2 will be null as well. And then if I really want that, depends how you're interacting with the language, you can assert it. That's the double exclamation mark. There you can assert that it's not null, and then you hopefully have it's not nullable. Otherwise, you'll get a certain error during runtime on that. And what's quite nice is now that you can really work on these elements here and do that. And you really have a typing system. So if you have a non-nullable type, you are sure that it's not nullable. So you don't need to have this millions of null checks in your code, which is really nice. And one thing that I've also hidden in that slide, for those that know Kotlin a bit, so it's the val and var difference. So you have val as a read-only, a final immutable type, which is always quite nice. So if you have a variable, you write it as val, you have it as immutable, so you can assign it and then use it, but not set it again. And if you're using val var, that's the same as in Java nowadays with a var. It's just a variable holder where you can use it and overwrite it later. That's already two things that you're seeing here that are helping you a bit on null safety and also on type safety. So if you're using val, this feels a lot of shorter than having a final string, whatever, in Java, and then still asserting that it's not equal to null and then be able to use that. So, and in the end, Kotlin is using the null feature as well. So in Java, you have this optional nowadays, which you are passing around and then asserting. And in Kotlin, at least, we are still using nulls if you really want that for nullability checks, where you can then pass around null and you have a type which you then get back and you are sure this can be null. So I'm doing null checks on that, or I'm using this. So the classical one would be, for example, Spring repositories. If you're using them in Kotlin, they are returning you a question mark type, which would be then you get it or you get a null if you don't find it by the ID. And if you use it in Java, you would get an optional of that. So where you then need to get that and use that. And the good thing is that you explicitly test for usability, or you are aware that you need to test for nullability and then can use that. And this hopefully also answers a bit your question, Sebastian. Okay, so at least one of the things. So another thing that I guess Java is catching up with those records, but it still feels different. So you have data classes in Kotlin, which helps you a lot on boiling down your boilerplating in Java, which sometimes, most of the times, feels like a nightmare if you're not using Lombok. So the classical one, you have a data value object like a book here, which contains some values, so a string, some authors, an ISBN number, and a type, which looks quite easy. So in Kotlin, I declare that as a data class. I write these as vals, as hopefully the title doesn't change that often. What will bring that to me is I get an automatic equals and hash code generation for the fields that I have. I get it to string. I get other things like a copy method, and yeah, it blocks inheritance. So I can inherit from interfaces or implement them. I can inherit from other classes, but I cannot inherit from data classes, as Java is always the one, at least in my perspective, mixing the use inheritance with the interface inheritance. There's always a tricky thing what you want to do if you want to inherit behavior or if you want to inherit data. And Kotlin decided you cannot inherit data, as it's weird because you end up with a subclass which only uses parts of that field of your parents. So they disregarded that and said by language definition, we don't want to have that. And yeah, these four things here would generate to a bit more of the code on the right side. So I've left out the component functions. I've left out the copy function. That's what you would need to write in Java to get not even the same thing, because I have val and there are non-null, so I don't have any null checks on the right side. So this would even boil down in Java code to even more than you see here on the right side, which is quite nice, as it reduces your code in your code base by a magnitude of these things, as most of us have tons of data classes flying around. Yes. The answer is, so this copy does a deep copy, but you can also say you don't want to have that. Depends what you want, but yeah. And you can even, I can now switch from the thing to my IDE, which you hopefully see. So if you take a look here, I have my data class. Can you see my IDE? Okay, so I have my book, which has a list of 2 authors, which is the Java to Kotlin, a refactoring guidebook. And I can copy that. And later I'll also talk about name parameters, where I can then override parts of that, which makes the code quite small here. And I get my copy of that with a list and a change type, for example. I only deliberately change parts of that in a copy. And that's quite nice. I can also leave that and then just take the copy as is and then use that further to continue. Where's my... Come on, PowerPoint. Yes. Okay. Questions to data classes. Look at the time. We still have a lot of time. So, and of course, you won't see a lot of getters and setters in Kotlin. So variables are by default private. You can, of course, make them public, but that's really a nightmare. And if you use it from Java, you have your getters and setters, which you are going to access. You can also override them in Kotlin if you want to explicitly say how they should look like. If you want to have different behavior there as well, everything is possible. And it's not like in Java, where you have at least sometimes these annotation hells, like in Lombok, where you then have anonymous annotations to say how getters and setters should look like when you want to generate them. But in Kotlin, they are just functions that you can really define with language features. Okay, so one other feature, which is, I don't know, it's an advanced switch form, I would say, the when. So Java is improving that a lot. Also now with Java 17, there were improvements. And then the benefit of the when form here is that I can use that as an expression. So I can have here a score function where I say I want when the score is 9 or a 10, I want to return a perfect, or if it is in between 6 and 8, good, and so on. And I need to have an else block, which is also something on Kotlin that they name exhaustive when. So if you have an enum or something, or a range where you want to have your when on, you get a compilation error if you have not an exhaustive when, which is sometimes the difference to the if in Java or the switch, where you don't need to have an exhaustive check here, but at least in Kotlin, they decided by language to do that, which is sometimes nice. And here I'm also using that as an expression in the normal language where I can have it as a return argument. Questions? Yes. I've sealed classes on my advanced Outlook on follow-ups. So sealed classes is also a concept in Kotlin, which I would love to have in Java a bit more. And they are in Java parts, I guess. But at least now you have a sealed class in Kotlin. It's an inheritance and a unit where you need to express every class in your sealed unit. And you can't inherit and work on this from the outside, which is quite nice if you have a closed block, like, I don't know, events, where you say, okay, I have these 5 events and I seal them together and they're one place and not used somewhere else, which is also quite nice to have that.
Jan, sorry, I have a small question. So the int type that you use here for the score parameter, that's like the integer object type in Java, or is this like the primitive int number type?
So the int is just a check that it should be.
Sorry, the int.
That's an integer. Yeah,
that's an integer which is, so I'm not like fully Java expert, but in Java the integer can be defined or null, right? Is in Kotlin as well the same way? So like in this when statement, can it be like null a value of score?
No, so it's so there's no primitive type in Kotlin. So everything here is non-primitive.
Okay.
And the int is a class which I can just normally use. And as it doesn't have a question mark, it can never be nullable.
Okay.
And of course, it can be 0 or negative as value. That's why I have an else here, but that's a good thing here, that you don't need to distinguish between primitive and non-primitives here.
Okay, that's cool. Yeah, because I thought that might be the same as in Java. Okay,
you can
cool.
even
Thanks.
do more fun things soon in a few slides when I'm talking about extension functions.
All right. Cool.
So, question from Daniel: if the immutable collections are similar to data classes, maybe we can elaborate this after the talk. I'm unsure about the question exactly. So at least in Kotlin, you have everything is immutable type. So you have immutable list, immutable set, and whatever, and immutable. And there you can just use normal generics in Java. And these are then just normal Java stuff, but let's see later maybe if no one else could help on that question in between. I already teased this with the extension functions. One interesting thing in Kotlin, which is also quite interesting as they're using it a lot in their own. So extension functions are, you can extend existing classes with new functionality, which can either be function or properties. I just focus now on functions for this talk. Those are dispatched statically and compiled. And I put danger here on this slide, at least for, I guess we'll see it later probably in the talk from Ralph would be my bet. So if you at least start with Kotlin, I at least had the experience from developers that they usually try to overuse that and use that as much as possible, because that's a cool, nice feature where you can extend existing classes with tons of stuff. But at some point you will figure out what makes sense and what not. And that's also a way how to do it. In the end, it's just, in the end, most syntactic sugar. There are, of course, patterns for good uses for, so here you have an example. I just have a normal string, which you can use just, I'll show it in the code soon. And I add an extension function escape for XML here, where I replace elements in the strings that I can do. And then I have my hello world string, which I want to escape here. So I just have a real classical Java string. And then I have my templated string output here, where I can then see what's that. And I can even use that further. For example, if you are using in Kotlin the classical map or each or filter or whatever, they are extension function in the standard library that extend the classical Java code and the Java list on features. I'll show that soon, where you can just extend what you have there. So you are importing, where you want to use that, your extension function. So just like you import a class in Java. So, and then you would have two trim functions in two different packages or classes, and then you on the place where you want to use it, then you can decide which one you want to import. That's a cool thing here. And yeah, you can't override existing methods. As it's dispatched statically, you'll get a compile error with that. It's even further bit. I'm later explaining a bit how overriding in Kotlin, what are there for restrictions anyway. Kotlin is a bit more strict. But what you can do is really add behavior. So for example, here, this escape for XML, you can enrich your things. So we have before seen an int where you can also add things if you are having number conversions or whatever you want. Which is also good if you have a library that you're importing. You're using a standard, I don't know, message bus library, which you want to enrich for convert to my specific entities that I have in my application. So you're extending the classes that you get from that library to get your own class back, which is a quite nice feature, as you are exactly in that field. So you are in that data class, you are in that string, and you can use the methods of that class because it's compiled into this class as well. So you can access this and access the fields in that class, which is really nice. And yeah, there are a lot of good uses. So example, like you see here, so classic good uses, a string reverse is, I guess, a classical, or a transform from one type to another with no arguments. So the to int or to list or to whatever you want to have there. Or if you want to have a fluent API change and want to have that, or if you just want to have some syntactic sugar at some point, where you should be avoiding that is, of course, if you have complex methods, if you have some IO operations or some behavior in the background, like start my web server or something like this, or if you have things that change your global state, like set my system time or whatever. It's also frowned upon multiple parameters, so usually you try to have none or one for extension function. Everything more screams like more like a classical class method on that. But yeah, they are one of the biggest things, at least in Kotlin. And also interesting enough, Kotlin is doing either on dog food. So lot of the standard library functions from Kotlin that you're going to use are extending Java. That's one language decision, which I'm also covering later, which is quite nice. Not more questions to that. So now the last thing, so one more thing that I've also shown a bit, which is really nice in Kotlin, which is sometimes a pain in Java. So you can define and provide default values to parameters. You can name parameters from your caller. So here in this example, I have this fancy ASCII border where I have a character which I have predefined to be the equal sign. And I have a default length of 15. We're just fancily printing that in a new line. And now I can use this method in different ways. So I can leave it empty, then I have my 15 equal signs. I can override the length, which is the second argument, without need to redeclare the first one. I can do it like in Java, where I can not name it, or I can even name both and change the order, whatever. The nice thing here is that name parameters help a lot to see which argument you are meaning. So the classical one, if you have multiple strings or integers and you're refactoring or changing, it's always a lot nicer from the client side to use the named arguments to specify what exactly you mean, because you're also then independent of the order and can refactor your code more easily, and everyone can understand what you want to do. And with the default parameters, yeah, in Java, this sometimes really feels messy to just have a default that you can use. And I'm always curious how this can improve at some point, which are at least some small things which are a nice thing about Kotlin. And like the data classes, they've made it now with the records into Java. Let's see for the rest what they're going to add step by step. Last but not least, for today, from the simple language features, I wanted to show you Smartcasts, which is an interesting feature. So every one of us in Java has the fun of casting around and testing, and then needing to cast and hope that everything works out. Kotlin is a bit smarter on that. That's why it's named obviously Smartcasts. So the idea in Kotlin is you don't have an object. It's named any here in Kotlin, so everything can be an any. And what it's doing is, if I'm writing is as a keyword, Kotlin is doing an implicit smartcast. So here in my when, I have when my argument is an integer, I can then directly use a +1 to increment the integer value by 1. Or if it is a string, I can use all methods that I have upon my string, or if it's an array, I can use whatever I have in my sum. And I can then use the generic method that I have kind of here in all different ways. I can also use an object as a string and then directly use whatever features I want to have that, which is a nice feature, as a lot of us in Java see castings around and generics, which at least personally feels for me always a nightmare in Java, as you always have the use side variants in Java. In Kotlin, they decided to have it differently. So you don't have any wildcards in Kotlin. So you always need to at least say what you want to have there at least. And you have different types of flavors of generics. So you can have, say, if you want to have an variance out, so saying where you're producing a generic and using that, like in a method where you're an interface where you're putting that in, and if you're next, which is using that type. And the classical one is the contra variant, yeah, where you are consuming a generic but never producing that. So you have in Kotlin the two differences between I'm getting that or I'm producing that, and you have two keywords with in and out in Kotlin to say what you want to deal with that. You can write null as any question mark, of course, and null is not nothing. So it will, I cannot assign a null to an any, as an any is a type and it's null safe. So I need to say any question mark, otherwise I cannot assign a null to be an any, which I can also finally show. Will already give me a value that I can't have on any, and then I need to really explicitly cast it as a nullable any to be able to use that. To answer that question. More questions? So there are, of course, more Kotlin features. I just picked out a few. I also have some in later where you can see and continue on your own, but these are the most prominent ones that you are encountering when you are taking a look at Kotlin, and which help you for a start, hopefully also in that order.
Can you maybe talk a little bit about like these, like private, protected, public? Is it like identical, or does Kotlin have a different concept for that?
It's kind of identical, but you have different defaults. So default is private by default. Make it public if you want. I also have some on my language decisions feature later, which deals with inheritance, for example, and override. But usually you have the good things. So it's a lot easier. So functions are by default public. If you don't say it differently, you have the variables private by default and stuff like this. Okay. And even though you have not seen it yet, so always what I've shown you doesn't have any classes. So I just have my Kotlin file where I have my main function, not even in a class, and just have a Kotlin script, as I don't need a class to write that, which if you have a main application boils down tremendously your code, as you just start with fun main and then just write down what you want to have. Or in Spring, you don't need even to have the brackets, so you just have your app in a class and be good. So let's talk about some language decisions, because some of these you need to be aware of. Some might be a bit weird, some make sense. We already covered, for example, the data classes cannot be inherited, which I like. Others might disagree. There's a lot of discussion on that, but yeah, let's see. Interesting enough, for example, all classes and functions are final by default, which is really nice in Kotlin, because you can't inherit just everything like in Java. I inherit God in the world and implement that. So everything is final, and you need to explicitly say my class is open or my function is open. And if you write it as open, you can override it then in your subclass. And then you just write override as a keyword. It's not a Java annotation, it's a real keyword in your language. The fun stuff here is that for Java frameworks, of course, they are relying like proxying for hell, like Spring and all others, and they proxy your classes till eternity. So that's why you have these fancy all open plugins that you are plugging into Gradle or Maven, which are opening your Kotlin classes, or depending which classes you want to have opened, to the world for getting that, which yeah, is the downside of this approach here currently, but it's improving. At least for Spring with Hibernate, they are nowadays so that you don't need to have these for at least the Hibernate classes and repositories anymore. Now that's, in my perspective, it's a nice feature. At least from a coding perspective, you as an owner of that class can decide who is able to extend your class, which is always, if you are thinking on a library, a nice thing. But sometimes it's a bit weird. And then you've seen a lot of things. So the nullability in Kotlin. Here they are also taking the defensive approach in Kotlin. So Kotlin says by definition that everything that comes from Java, any reference, any variable may be null, which makes sense because, yeah, you never know what the Java is doing there. That's why even that's, if you take a look at literature or anything, they are called platform types. So you need to test for null before you can assign that to a non-nullable type. Kotlin is a bit intelligent on this side. So if you have JSR 3 or 5, or if you're using the Lombok annotation null or JetBrains or Spring annotations or whatever, Kotlin is using that, and then you can just use it and you are in a non-null way and can be doing that. But be aware if you are starting with mixing Java with Kotlin, that everything that in the Kotlin code that you are doing will always need to have these checks, except if you're doing these annotations on the Java part. And then ramping up these things. So we have the final by default, which we covered. We have the platform types already set in the beginning. So there are no primitive types, which is nice. Also Groovy, for example, set in Java and Scala as well, I guess, that there are no primitive types. So I guess every JVM language except for Java is saying that. You have no implicit widening conversions for numbers, which is, yeah, you can do that. And then you have the standard library of Kotlin. So a lot of the things that you're seeing and that we have used are in the standard library and not part of the language, which is quite interesting. So at least in Kotlin, they tried to make the language small and moved parts into the standard library. So it's quite small what you can doing there. And the good thing is that they decided to use extensions to the Java standard library. So what you've been seeing, I can show you the code, for example, if I'm working on this map or on any function on a list. This is an extension function to a generic Java list, which is quite nice. And Kotlin has a lot of optimizations for this stuff, especially if you're taking a look at Android development, which helps you a lot and tremendously on these areas, which makes sense as you've seen that this is the standard library nowadays for Android, but it's catching up also on the backend side. Any questions? Let's see for the rest. So these are kind of the major language decisions and the features that we'll encounter. Of course, there are a lot of more, but these should help you a bit from a Java perspective to see what you will get if you're doing Kotlin. And as said before, you can mix that. You can use Kotlin with Java. You can decide on your own if you say that's nice. So you've seen the data classes that get boiled down to a lot. Also, if you have a normal class, you don't need getters and setters, and you can just work with that as you want. You still have always your private properties which have getters and setters in the end, and going through these if you are unsure and want to have some checks on that. And you have the nullability was also helping a lot. And now I wanted a bit to take a look on the outlook. So that's of course not the only thing. So if you're taking a look on Kotlin and on features, which I really completely left out today, as I've done it from a Java perspective, especially coming up this year and the next year, Kotlin is really forcing a lot more on this multi-platform approach. So also if you take a look on JavaScript and native and mobile development, there are a lot of topics where you can take a look at, where you can also use Kotlin to generate and use your code. Is one of the higher advanced features are coroutines in Kotlin, which helps you with asynchronous workings and behaviors, and which, at least also on the Android side, improved a lot of stability and performance of a lot of Android apps. You can inline functions. So if you are using Gradle, you will be using tons of inline functions of Kotlin, which you can just click on and see how they are working, which helps you a lot for if you want to do a custom DSL. Of course, I just touched the in and out types and the variance checks of Kotlin. There's a lot of more things on generics that you can take a look at. Kotlin is fond of these higher order functions, so you can really have functions and passing them around. Nowadays in Java it gets also easier, but yeah, in Java, in Kotlin, functions are real proper elements that you can use and work around, and alias and name and seal. And then, yeah, what I just touched a bit with a question from Sönke, and also on the remark with sealed classes, and a feature that's not so often used since Kotlin 1.3 are contracts, where you can say that you have a contract that this method, for example, always returns a type of this and something like this, and or it returns a non-negative stuff, and which is then also evaluated and used and compiled, and you can use later with the other classes and the callers of that, which is a feature that's also a bit more advanced, as the syntax, at least for me, is a bit wonky. And then last but not least, so a lot of features are happening in Kotlin. Here, for example, just the top 3, my personal highlights of the next quarter. The compiler of Kotlin, they have been working on that to improve that for a longer time now, as they have this multi-platform, and they've still the old compiler that was done in 2010 is still the basic of the current Kotlin, and they have been on that for multiple years and trying to improve that. And 2 years ago was a decision to rework it completely from scratch with a modern plugin infrastructure and with the multi-platform that you want to have in mind, which I also tested a bit, and it gives you a lot of speed improvements already. And one other thing is then, of course, the release of the multi-platform in a beta way, so that you can test on stability and robustness. You can already use that to generate JavaScript and use your JavaScript frameworks. And one thing that I also didn't touch is how to deal with statics, as Kotlin doesn't like statics and doesn't support static. A lot of Java developers are screaming about that, and they thought about a long time how to deal with that. There is a concept like companion object in Kotlin, which is of band-aid on this. And they now decided to introduce the concept and the keywords on namespaces, where you can have an ephemeral object without instances, which compiles to static JVM to help the migrations of these statics and the Java developers that love losing statics all over the place. Yes, desktop native is not even Graal native, it's native code, as it really compiles to native code. And it's similar to what you get with Graal. Yes, and it works with Docker. And it's really nice, and you can use it. So, and then last but not least, my last slide for today, then I can answer questions, or we can take a look on a bit of coding, and then I would pass to Ralf for the next thing. So if you want to try it out, go to try.kotlin.org. That's an interactive documentation site from Kotlin, from JetBrains, which is really cool. And the nice thing is that everything is executable. So you have the Kotlin shell, which is in that website, and you can just write there the code, test it out interactively. And there's also a link collection, kotlin.link. Kotlin is awesome, is that page where they're collecting tons of follow-up literature on Kotlin and videos and courses and whatever you see. But these two are always good starting points for taking a look further on your Kotlin journey if you're interested. And then I would be now interested on your questions.